Average rate of change is the slope of a function over a given interval. We also refer to the slope as the rise over run, the change in y over the change in x, which is represented as delta y over delta x, and also using the slope formula, y2 minus y1 over x2 minus x1. Because a quadratic function makes a curve and not a straight line, its rate of change is not constant. Between these 2 points, the average rate of change for the function is 1, but between these 2 points, it is much steeper. In example 1, we're going to use the graph to find the average rate of change over the given interval. The numbers in the brackets represent the x values of the points that we're going to use to calculate the slope. The first one is x equals 0, so we'll locate the point on the graph where the x-coordinate is 0, 0, negative 1. The second number in the interval is x equals 1, so we'll locate the point on the graph with an x-coordinate of 1, 1, 2. In this example, I'll demonstrate calculating the slope simply by counting the rise over run. We went up 3 and to the right 1. So the average rate of change for our function is 3. In the next example, the x values given in the interval are 3 and 4. First, we'll locate the point on the graph where the x-coordinate is 3, 3, 0. Then we'll locate the point on the graph where the x-coordinate is 4, 4, 3. In this example, I'll calculate the rate of change using the slope formula. We'll subtract the y's for the rise on the numerator and the x's for the run on the denominator. We'll let 3, 0 be x1, y1, and 4, 3 be x2, y2. Subtract in the same order for both the x's and y's, and be careful with your signs. In example 2, we'll find the average rate of change for the function between x equals 0 and x equals 2. We'll identify the point where the x-coordinate is 0 at 0, 2, and then we'll identify the point where the x-coordinate is 2 at 2, 26. Then we'll determine the change in the y values and the change in the x values and write our ratio for the average rate of change. We'll subtract the y-coordinates on the numerator and the x-coordinates on the denominator. 26 minus 2 over 2 minus 0. This gives us 24 over 2, which simplifies to 12. In example 3a, we're looking for the rate of change over the interval 3, 4. We'll identify the point with an x-coordinate of 3, 3, negative 2, and then we'll identify the point with an x-coordinate of 4, 4, 0. Then we'll count the slope between the 2 points to find that the rate of change is 2. In example 3b, the given interval is 4, 5. We've already identified the point on the graph with an x-coordinate of 4. So now we'll locate the point on the graph of the parabola that has an x-coordinate of 5, 5, 4. Then we'll count the slope between the 2 points to calculate the average rate of change. The change in y is 4 and the change in x is 1, so the average rate of change is 4. Comparing the two, we can see that the interval 4, 5 has a greater rate of change. When asked to calculate the average rate of change, you may see the interval written using a compound sentence. For example, negative 3 is less than or equal to x is less than or equal to 0. The compound sentence and the interval are both telling you to find the slope between the points where x is negative 3 and x is 0. Now you're ready to practice on pages 32 and 33 of your packet. Good luck!